All right, hey, thanks everybody for coming. That's actually a lot more people than I was expecting in this room. The rooms I was in yesterday was a lot less intimidating than the intelligent faces here. We're going to spend the next little while talking about building applications, primarily web-based front-end applications. Of course, this is the front-end track. Spoiler, we will talk a little about the back-end, but only because it's impossible to front-end applications without a back-end of any sort. First, let me introduce myself. I'm Dustin. I'm a dad. I will have dad jokes over the next 45 minutes. So, yeah, I have only one 2-year-old and a dog, if you count him. But a little bit about my history, the context of this talk, where I'm coming from. I've been building web-based applications for the past 3 years, primarily as a front-end developer at a place which, according to this little space volcano, it's called Skookum. We're based in Charlotte. I've built a wide variety of apps for a wide variety of customers, coming from a t-shirt designer in the browser, like a Photoshop Illustrator mashup, similar to like Custom Ink. I've built a lot of internal admin tools for businesses, basically glorified spreadsheets. Built a trust-based job network where the two parties, think LinkedIn, where the employers can't know who you are until you tell them who you are. Mobile device management is a recent application I built. This company had, everything to manage their employers' companies, but they needed an interface that actually worked on mobile devices, as well as like a entertainment program viewer for like 2 weeks of entertainment on your television. Throughout this, I have been changing tools every single project. This is by far like not a full list. From like the build side, I've used Require.js with AMD, Browserify Webpack with Common.js, the asset pipeline. I have no good things to say. Ender, which is kind of a build tool, kind of not. Angular, Knockout, Ember a little bit, jQuery, no JavaScript framework. And that's only covering tools on the front end. Of course, we could also go into CSS preprocessors and HTML preprocessors, which I've also gone the full breadth of those. And every single time I finish a project, every single time I keep saying, like, why am I changing tools? Every single time I finish, it's like, seriously? Like, man, there has got to be something better. There's always a bad taste left in my mouth. There's always problems, usually more on the human side than the technical side of building these applications, how to scale them and maintain them and add new functionality and features. And in that context, there are specific challenges for us as UI developers as opposed to somebody who's like working on the data layer. And then beyond that, next we'll talk about the specific challenges of also web developers. So UI development, we work with both an asynchronous environment where the users also expect direct manipulation. So what do I mean by that? The asynchronous environment is you load up an interface on a page, on an app, whatever, and you have no idea what's going to happen in what order, what the user's going to click next, what's going to happen. Once they might start firing off a chain of events, you have some idea what's going to happen for the next 10, 20 function calls. But as a whole, like, you don't know exactly what the user's going to do. So that's the asynchronous environment you're working in, as well as the direct manipulation, where when they mouse or bring their mouse over something, they expect it to respond. If they are on their touchscreen and are dragging something around, they expect it to be directly related to what they're doing in the real world. And also, building applications, you have evolving requirements. How many of you have received only one single -final dot whatever extension during an application, or like -final v2 date stamp -final round 3? That's a constant. It never doesn't happen. Double negatives. And the other tricky part, if you were in James Pierce's talk on React just a little bit ago, is managing state, especially across an app with diverse requirements where there's things in one corner, and then you actually want to render something else on the other side that's like a composite of that information. This is a quick preview. I always get way too ambitious and try to like build real things for talks, during talks. And so I had my friend Steve, who's up here on the front row, designed this application for me, trying to like express real problems you have. So you start off with, let's pretend this is the actual final, which is a to-do app, because everybody loves to-do apps, and they totally express everything you deal with in the real world. Step 2, you actually like have to change it. So like initially you just have a list, you add items, you finish them. But then they come back and like, actually, we got this in the real world, and people want to be able to edit these things. And so our idea for how to edit these things is actually dragging things out. But you've already written your application. How are you going to add that functionality? What tool set are you building that's allowing you to do that? So on and so forth. So we'll come back to this example a little bit later. The challenge of the web development platform, in particular, HTML, CSS, and JavaScript. I've not done much native development from my experience and understanding. They don't have the separation concerns of presentation, document, and behavior, or whatever we call it. On the web, honestly, I think that separation concerns is a lie. I think it's actually doing a disservice to our industry, especially those building more application-style things and not like CMS-powered websites. Because why would we separate our concerns between just like this arbitrary technological divide? When you're building a tab component, you're not building like, hey, here's some structure for a tab, and here's what it looks like, and here's a behavior on top of it. That's like one individual component. Like you can't divorce those things from each other and still have a tab. So lastly, and this is going to cover the human problems with writing HTML and CSS, are the semantics and structure of things. Once again, this is not primarily a technological problem. It's the human problem. How are you going to manage the complexity as your app scales up? Nicholas Scalagus of Normalized CSS has done a lot of work with this and written a lot, as well as others. The default that most people go to is the big ball of mud HTML, CSS. You write HTML, you need to style some way, so you just add some arbitrary class. And then it just grows and grows and grows and grows from there. And the only person who knows what that is the original person who worked on it. As soon as you have more than one person on that project, that transfer of knowledge and that ability to scale that quickly falls apart. So Jonathan Snook wrote SMACS, which stands for Scalable and Modular Application Style Sheets, I think. BEM, Block, Element Modifier, Object-Oriented CSS, and Suit. And all of these are just more rigid, defined ways to structure HTML, CSS, and how do you actually compose these things that are inherently tied together into one unit. And then lastly, the components and composition of these components. So once again, we're back to our typical tab component. That component is, in and of itself, one thing, but it has arbitrary things inside of it. So how do you compose those arbitrary things inside of it in a sane manner that's easy to maintain, that's easy to move forward, that's easy to add or remove functionality as requirements change? And then taking a step further, so beyond just the HTML, CSS side, what are the trade-offs we have to make when choosing our tooling? We can either go the traditional approach and just do server rendered, use Rails and Haml or .NET or Node and Jade, whatever you have. That's great. It's really easy to get up and running. The conceptual model behind that is really easy. Honestly, we've been doing that for a long time, and it works really well. But you don't get like that live dynamic, like single-page application thing, which is the other approach we would take with a tool like Angular or Ember or Knockout, where single-page application is maybe a little bit too tight of a description for this. It really can go beyond that, but kind of like HTML5 means everything on the web. I'm going to use this to refer to everything that's client rendered. And those tools, like you lose the benefits of search engine optimization, the first page load time. The client actually has to download all that HTML, all that JavaScript, execute it, and then render it. So you're greatly deferring that time to like first experience with the user. Or you do have this one other trade-off you can make where you can take on the burden of rendering it both on the client and the server, repeating those templates, rebinding those events, managing the DOM, and pulling your hair out. Or you could use the Angular approach, which is render it through Phantom.js and serve that up. So when I'm choosing tools in this context, knowing that state management is like a part where every project falls apart, most bugs appear through trying to manage the state and like keeping things in sync, knowing whether we want to do a client-server architected solution, such things. There's a few things I take into mind. There's things I don't care about at all. The time to first feature doesn't really matter. Like how quick can I bust out the first feature? Like can I be up and like delivering a pivotal tracker story tomorrow? Like who cares if it's going to be a 6-month process? Like that first feature is the important part. Is how is it going to scale over time? The acronym, which I'm going to use as a pointer to the popularity of an application, such as mean or LAMP, also isn't a good criteria for what tools you're choosing. The testability of it, especially in an engineering department, I might get a little bit of flack for this, but the testability of it really isn't as important as the maintainability. To express that, I will talk. I'm sorry, I'm going to crap on Angular. I try not to. Angular, of all the modern front-end frameworks, has the best testing story of all of them. After using it, I think it has to be, because the only way to maintain Angular is to test the crap out of it. And even then, like, yeah, it can be a mess. Doesn't matter how much magic there is in it. It doesn't matter how many features there has or what the size of the framework is. The thing that do matter is how much cognitive load are you putting on your developers every time they have to go into this code base, whether for the first time or coming back 6 months later. How difficult is it to get back into the context of what they're working on, what they're trying to accomplish? What does this application framework give you for the flexibility for change for those evolving requirements? Do you have to actually like throw out huge chunks every single time, or does it allow you to like just tweak, move things back and forth? And that's directly related to the maintenance overhead of the tools that I would like to choose. Because quite frankly, humans forget. The number one thing I'm trying to defend every time I write an application is against myself. Because I know I'm going to make mistakes, and I know I'm going to forget what I wrote. I can't tell you how many times I do end of a project, I look back like, holy crap, how did I write 100,000 lines? I don't remember any of these. And that's like not just me. That's across everyone. Everyone in our team has that. Controlling the complexity of the application. Once again, to crap on Angular, the team I was on, you have controllers. I've never seen an Angular controller that was less than 1,000 lines that did anything like reasonable. But in addition to that, you're bleeding your logic all over the place. Not only is it in the controller, you have directives and scopes and probably like 50 other things to care about. And then inside of your HTML, once again, I've quit using Angular, but I've never seen a project that didn't have forked behavior inside your template. So once again, you have like a bunch of if statements in a controller, a bunch of if statements in your HTML, random bindings, event chains flying out of control. So what does your tool give you to help actually combat that and keep things sane and easy to understand? Another thing coming into projects, there's always like, in the 4 quadrants, there's like the known knowns, the known unknowns, the unknown knowns, and the unknown unknowns. And those are the ones that are always going to bite you. Every single time, they always exist. Just like you can forget what you're doing, at least I forget what I'm doing. There's things you don't know going into the project, in addition to the fact that the requirements are going to change regardless. There's technical challenge, there's human challenges, there's what does the user expect, what does the business expect or want to accomplish, and what are you going to run into that just like doesn't behave any way that you expected it to. And that big space is for an image that's not there. So what tools can you choose that help you fall into the pit of success? There's an article, I'll post to it whenever I put my slides up. It's basically the opposite of falling into the pit of despair. Instead of going down a project and like constantly getting worse and worse and harder to maintain and more expensive to do small things, how can you make it easier to do the correct thing? How can you make it easier to do the maintainable thing? So what if you didn't actually have to make all these trade-offs? What if you didn't have to choose between server-rendered, client-rendered? What if you didn't have to choose between like a rich single-page application or a document-based application where you're like sprinkling jQuery on top? So where I want to come into, I finally built a project with the tool set that I'm in love with. I actually feel guilty about how much I enjoy this tool set and like how much I'm trying to get like everybody on my team to switch to it. So at Skookum, we've actually switched most of our projects to React, so I'm actually pretty excited about that. And in this process, I'm not saying the tool is, like the code is perfect. I will complain about my code to no end. But the tool itself actually helped me. And when I had to make changes, when I came across things that I didn't expect on day one, it provided easy paths to move forward and actually fix those things and address those situations. So the module system of choice is Webpack, by far. If you haven't heard of Webpack, it's similar to Browserify. It works on Node. It's part of the Node platform. It allows you to consume Node modules, but it also consumes AMD, like Require.js, and such things. So as an author perspective, even a front-end person, like writing in Common.js is just very natural, very easy. In addition, it allows you to fall into success. Like you can write naively, and there's probably a plugin already there to help you like optimize it after the fact. Quick story, the other day on Twitter, this guy, Dan Dean, sent a tweet out saying like, doing multiple builds with similar components that they depend on, like extracting that out, is crazy difficult in Browserify, making me look into Webpack. So I sent him a link to how to do it in Webpack. It was like literally 3 lines. In 40 minutes, he went from Browserify to Webpack with this new plugin, and it worked perfectly, no problems. Those are the kind of situations I mean when I say like the pit of success. There was no way he could have predicted this up ahead of time. He didn't have to worry about it while authoring. He just wrote it the naive way, like declaring his dependencies ad hoc, and at the end he just said, Webpack, go pull out all the common dependencies into its own build, and I'll include that on my own, and then give me all the other ones to include on the pages that require them. So module system, that's amazing. And then building user interfaces, James Pierce, thank you for doing my intro talk. React.js is freaking phenomenal. I cannot say enough good things about it. I'm actually going to show you in just a minute a few different examples of the power of React. I cannot recommend it enough. So this is the live coding section. I actually have a problem. I live code at almost every single event, and someday I'm going to fail horribly. Hopefully it's not today. So we're going back to the tab. Really generic. I'm sure all of you have built the tab control. This up here is the Bootstrap Tab Control. So if you want to build a tab, once again, let's go try to look at what a tab control looks like. Bootstrap tab. Using the internet while talking. That's never safe either. Not that button. All right, yeah. Everyone knows what tab is, except me. There we go. All right, so you have some stuff, and you can tab between things, and it displays or doesn't display. Hides or shows. So again, like that tab is not the HTML, it's not the CSS, it's not the JavaScript, it's not the behavior. It's all of those things combined into one composite piece. But if you want to do that with Bootstrap, first you write this unordered list, and you have to know these class names. And also, if you care about accessibility, which you should, you need to add the role attributes. Then you have these non-accessible anchors because they're pointing to nothing instead of where they're going. And then later on the DOM, you have, again, just arbitrary divs with arbitrary classes attached to them. So that's just your tab structure. But if you actually wanted to look like tabs, you need to come down here. And this is just a subset of the CSS it includes. Keep going. Is that large enough, by the way? All right. Everyone in the front says yes. All right, so that's just a subset of the CSS we're bringing in to get the presentation the way we actually intend and need it to be a tab. And then you add this jQuery where you have to, once again, know what your DOM looks like, bind those events, handle whether the DOM changes to rebind those events, run the default, and then call, once again, money this tab show. Or if you want to, based on a different event somewhere else in the DOM, or based on like an AJAX request, change things. Once again, go dig into the DOM, fire this arbitrary event with an arbitrary string. So, but it would be nice if you could actually compose this and write this the way you intended. What if you could actually write, like, here's my tab. Oh, we have multiple tabs. And I have a list of tabs. And this is my first tab. This is my last tab. And then down here, we would have just tab panes, much more declarative or much more expressive of what the intent was. The behavior of it, we're like, I don't want to actually have to go and add that extra. I want it all to be part of one single unit. Of course, web components kind of give us this promise. If you're familiar with web component spec, it's coming through in HTML5. Google's very aggressively implementing it. Polymer is a polyfill for it. Polyfill, maybe on some parts. In my opinion, React is everything web components could be. So let's find my other file where this is actually working. All right, so this is common.js. I would consider this to be very idiomatic React. The top, I'm requiring my dependencies. Like, it's a declared express thing. I'm being explicit. I require these things for this control. And then I go through and I render them out. It actually doesn't matter if I put them at the top or at the bottom. And then my tab panels, once again, I can put whatever I want inside of those. I have hello, the world, with some images from random places on the internet. And then at the end, I'm telling React to go ahead and render this into this element. If you're unfamiliar with the syntax, it's called JSX. You can actually use React without it. It's really just like it's sugar over what it would actually decompose to. So once you run through the JSX compiler, it basically looks like tabs, tab list, and maybe more Lispy than you want it to be without any of the benefits of Lisp. So I'll just run the webpack command on here. I already have a tiny bit of configuration to say how to compile it. Build. Come on, where did it go open at? There we go. So I have a big cat saying hello. Do you get the dad joke there? And the world. There's actually like 2 dad jokes. Hello, kitty, and hello, the world. All right, so that's cool, but right now, this is actually pretty ugly. I just have an unordered list and a big white page. So Webpack gives us this very nice thing where you can actually not just bundle your JavaScript together, you can actually bundle anything else you want into it. So let's go ahead and say this requires tabs CSS. And to show you where that is, inside my scripts file, I have tabs.js, tabs.css. So save that, rerun Webpack. And now I have tabs designed by a developer. Again, this is really a beautiful model. I'm being very explicit about my dependencies. There's no longer this arbitrary, hey, this HTML actually requires the CSS. I can declare that anybody coming to maintain knows exactly where that's being required. Of course, since CSS lives in the global scope, somebody else might decide to try to depend on it. But it's at least a step in the right direction. So this is kind of like the intro to React, much more express, or much quicker and less in-depth than James did earlier. So let's go beyond that and actually start building our to-do app. All right, what branch am I on? All right, cool. So this right here, I'm actually working on a workshop that I'm going to be running in Skookum, at Skookum in Charlotte in the next couple of months on actually building out things with this model. And so this will be going up onto GitHub in the relative near future. It will be evolving, so you can actually come follow along. It's relatively a fork of a demo by Ryan Florence, but it just gives us some really quick things to get up and running. We have, this is our entire Webpack config. My package.json, just requiring a bunch of Node things, and then my app. I have, oops, what button was that? The one problem with Vim is everything's a shortcut. This is actually way worse if you have a 2-year-old who walks up and starts smashing on your keyboard while you're working. Scariest thing in my life. All right, so this is my whole client. Everything gets bundled up into this. React's required, what environment I'm required, require all the routes for this application, and render that whole thing. So if you're familiar with really any sort of MVC backend architecture, this will probably look very similar. They've very heavily based it on Ember's routing library. Even though I will say good things about Ember, even though I don't use it. Maybe it's because one of my friends is he's excited about his Ember as I am about React. So it's declaring, hey, I have a route. It's at the root. When I call it, render to this thing. If anything else is requested, return this thing. Once again, render all of this stuff inside whatever we are at in the root. If you think of a typical application, you have a lot of boilerplate. You have this random stuff at the top that's always there. You have the stuff at the bottom that's always there, and then you inject it with a bunch of stuff in the middle. So this is definitely very, very optimized for that environment. React gives you other ways to get around that if you actually need to add stuff into that header or vice versa. That's neither here nor there, if that's a bad thing to say. So when I go to the home, I'll just get, congratulations, you have a client-server rendered app. So let's go ahead and run this. All right, let's see if this works. All things open, congratulations. That's really small. And to prove that it's actually rendered without JavaScript on the client, go to, I was doing this earlier, I swear. Well, I'm going to totally fail that. All right. Earlier, I was actually trying to build the entire application that ran both in the browser and in Lynx, which is a terminal-based browser, which you just saw. That's cool. Now let's actually start building on this and start building an actual application. So let's hop to step 2. And remember what I did. All right, cool. Now quit that. Who actually uses Lynx and can tell me what I'm doing? There we go. I had a coworker who actually checked his email in the terminal. Yeah, he was pretty gnarly. All right, so this was just some quick boilerplate. I have a header, I have a footer. I don't think this is actually tied up to do anything. I hope it doesn't, at least. Yeah, cool. Oh, wait. All right. All right, so cool. We actually do have an app that works. To walk through what this looks like. We have our root. So again, we're going to take Cryo React, render this structure. Anybody who ever needs to come and maintain it at the top level knows exactly where to go, and it's very easy to see what is going on. Once again, this isn't adding any functionality. All we're doing is rendering this stuff, including whatever page I'm on, stick that stuff in the middle. So what is that stuff? Let's go look at our home handler. And this is actually going to get pretty gnarly pretty quick, because I did that naive approach. I actually just shoved everything into one component. So we're looking at our UI. We have a number of things. We have our form that needs to be able to add things. We have our header. We have a list of things that are complete, a list of things that are not. That's first. A list of things that I still have to do, a list of things I've already done. And so, again, I'm new on the team. I don't know React. So I'm just going to write everything inside here. So when I try to say the React things, if you know HTML, think of it looks kind of like HTML with built-in DOM handlers that we would never want to do. React does some crazy black magic behind the scenes and hoists things up and does some very memory intelligent, memory aware optimizations for you, much better than you would actually probably do on your own. So here's my form. When I use this form, I need to take care of, whenever I submit it, add a new task. I need to make sure that I'm actually keeping the state of my application up to date with this value, this input. So let's split it out. So I have an input that has this name, new task text. Whenever I change it, just update the value, whatever the new state is. And whenever I submit, that's actually a different part. And then the button, which doesn't need to do anything because buttons by default trigger forms, so I already had that covered by handling that submit. So to tie this whole thing together, I need to, apologies. Let's just look at the add task. So whenever I call the add task function, give it the event, prevent the default because I don't actually want to submit the form if I'm executing JavaScript. Go to your task store, which is what our data model is. Basically, it's like your model of collections in this situation. And create a new task with this .state.new task text. And then reset the state so that input is empty. So every time I come up here and say, hello, with no text actually appearing for some reason, give talk, learn to write code. Yeah. Every time I hit enter, I'm calling that function, going through that tool chain. Everything's being re-rendered on the fly. So the mental model of dealing with React is I change something, just re-render everything. That's all I have to care about. I don't need to track those changes over time in my brain. That's pretty easy, but I added a task. So how does that actually ever propagate out to what depends on it? This is using a 5-minute implementation of Facebook's Flux, which basically means I have to manually, once again, explicitly declare that this component is dependent upon this task store. Whenever anything in that task store changes, listen to it and call this function. Call my handle task change function. Anytime anything at all inside that task store happens. And whenever I unmount, make sure I'm cleaning up after myself. So I call task storage create. And I'm generating a new task object and adding a new task. And that eventually triggers the change event, and it propagates back out. So again, it's actually very important that you only have one change event, and everything listens to that one singular change event. I'm not manually telling my application, whenever I change this thing or whenever I add this thing, because the mental complexity explodes as you start doing that in userland. Adding it's really easy. There's no effort at all to say hey, add this, keep going. But you have to come back and actually care about how those things are composed together, what these arbitrary strings mean. Once again, we're in a dynamic language. It's untyped. How are you going to keep that in your brain? So real quickly, we also are going to have our task list and just render the open ones, render completed ones. Each one is just a filter that goes through each single one, sees what the state is, and chooses to render or not render it. Does that make any sense so far? Kind of like the conceptual model of a task list. So let's quit that. I think this is the part where I actually want to do. All right, cool. So what's this look like to actually move this forward? What happens when we actually want to start breaking these components out into their individual composite pieces? We'll just start once again at a really high level. Start off, we just consider the whole thing one component. But now we actually want the form to go out. We don't want the form's details, the form's information to be bleeding all over the rest of this application, all over the rest of this file. We want to actually decrease the cognitive load of this one individual file and separate these things out. What does that look like? So I'm going to add a components folder where I'm going to start shoving everything in. Oops, that's not a folder. Components. I'm going to add a add form, add task form. And really, I'm just going to start very easily pulling these things out of, what file is that in? Home. We start pulling everything that has to do with that form out into this file. So a few things that you need to have for React, at least for the next half a version. Form, create class, render. So first thing, we just want to grab everything that needs to be rendered and just shove it over here. All right, so that rebuild. All right, so we still have a form. There we go. But it's no longer tied up. Hitting enter shouldn't do anything if I know what I'm doing. All right. Let's try one more time. I was over to pretend it works and keep going. Oh, there we go. All right, so I actually never brought the form back in. So clearly, I don't have a form. So let's once again explicitly declare that we need this form. Var add task. Add task form. And this is now going to become much more expressive for the next people coming along. It's actually not just an arbitrary form with arbitrary classes. It's this full piece, this full unit of work that knows what it does. It declares what it does internally. All right, and add form task. Oh, make sure you export your things. So it was right. The other part of the tool set that I like is I like the future. And so that's valid ES6. Facebook, from what I'm told, also uses a lot of ES6 internally. And so React comes with a small ES6 transpiler. But so in ES6, you can do things like object function literals or something. I don't know what they exactly call them. But I fat finger the word function like nobody's business. So it's probably like the biggest time saver for me. All right. All right, so we'll pretend this works. I'll just walk through the rest of the process and then go to a fork where I actually already did it, so I know it works. So the things that I care about inside this world are that task store. So once again, just go ahead, require it. I want to take the things out of the state of this world where I was actually bleeding multiple concerns into that. I want to pull that state out into its own thing. So this is already becoming more simple. So get initial state, turn text, and then take all the things that I had named very verbosely because it was where it shouldn't be and make it much more simply. Then add my add task. There. And that's all I actually need to do to pull that one thing out onto its own. So I now just create a new component, much easier to maintain, declares its dependencies, manages itself, ties into the rest of the app in whatever way it needs to. Doesn't really care. It just says, hey, add a new task. And then that goes ahead and tells everyone else that depends upon it, whether it's higher in the tree, lower in the tree, different page entirely, and tells that to update. And then we can easily, imagine how do I actually take more things and move them over. And running way shorter on time than I expected. So just for example, like this would actually be much more express. We could say opened task lists. I'm hyper aware of how I spell the word opened. I once spelled opened wrong for an entire project and had no idea until like 2 months later, I was up the project and heard other people saying like, yeah, that was really weird. Like open was spelled with 2 N's. So if I get to this situation, I'm actually divorcing those concerns from each other and becoming much more clear. And once again, this file would go from mega huge to just component will mount whenever things change, handle that task change, which basically means re-render the whole tree, and so on. So git checkout step 4. RM, RF slash, right? I told you I fat finger things a lot. Step number. There we go. All right, so to finish in the next 2 minutes, we now have these add task form, completed task form, open task lists, and we're feeling really good about our code base, right? We have a home page that looks like this. Someone can come along and really easily understand this open task list, this completed task list, there's an add task form. If I want to move things around, whatever, if I want to add another title for opened task, like that's really easy to do. I can even add new event handlers within this piece and not care about how it affects things below or higher or in a different part of the system. And then our developers come back with this great idea. So we have this list, once again, but right now they want us to be able to drag things around. They want us to be able to like flip this open and say, okay, like they need to be able to edit this thing, so let's have a swipe over because we want to make it like a native app on the web, which I'm all for. How do you add that functionality? In a traditional framework, Ionic, I'm assuming you actually just like add an arbitrary event handler. But I want to compose things together. I want to be able to decompose, pull things apart, and pull them back together in a way that makes sense. So what we really want to do is be able to drag this. We want to make this thing like something that's draggable, and have the draggable things manage its own state, and this continue to work like it did before. And luckily, I'm running out of time because I also ran out of time while writing this demo, so it's not complete. All right, so I want to change my open task list to being not just a label, but I want to have it be a draggable label. I want it only to be able to go left. That part's not implemented. But I want it to stop at 50 pixels. It's locked at 50 pixels. So how would you start doing that? In a different framework, you would start just bleeding that all over the place. Here, like the natural thing is actually to go and create a new thing, a new component that only handles dragging, and then stick whatever you want to into it. It doesn't matter. And so if you look at the draggable, like we're just have a div. The style is translated whatever way we need it to do. On mouse down, start tracking. If you care about pointer events, then do on touch down, touch start equals this dot start. You need to actually care about pointer events as well. I don't think React supports pointer events, but Microsoft has now backported touch events, so you're safe. Again, like this is a very conceptually simple thing. I have my start x, start y coordinates, and my current x, current y coordinates. Whenever I start it, just track whatever that start x and start y is, and then bind these other events. And then whenever those events happen, it's very simple to say, hey, just make sure like I'm within this limit in the direction I want to do, and set state. And that's going to reset and re-render this component and every component below it. So this is partially implemented, like my tabbing. So once again, I can just click and finish it, or I can actually drag things out, and it stops at 50 pixels. I have an example. I do have permission for the client to show you. It's 1,000 times beyond this. I cannot show it on the tape. So if you want to see like a much more expressive React app, it works on iOS, tablets, phones, Android phones. It's a very rich interactive, like I showed it to people and they actually didn't realize that it was a non-native app. and shows you how you can actually pose these things together. I would love to show you these things. I'm super excited about React. I think it'd actually make your team better, your projects better, and of course, getting the server client render thing in a sane, maintainable fashion. I think you'll be able to actually move faster as well. So that's all I have. Thank you.